Any questions from homework stuff? Yeah.
On 7.1, when you graded it, the question for 41, it said to use the graphic calculator.
Oh, yeah.
You wrote work. Show work on that. How do you show work?
No. So a lot of people haven't done the graphing calculator yet. I think when I signed it, I didn't realize they wanted you to use graphing calculator.
Oh, okay.
I kind of wanted to see table values, but later I realized, oh yeah, they're asking for a graphing calculator. We haven't even talked about how to do that yet. So
Yeah. Okay. Sounds good.
So if they ask you for a graphing calculator right now, you can make a table of values and graph it.
Okay.
We're going to get into the graphing calculator stuff after this first test.
Okay.
Yeah.
Sounds good.
Cute. Yeah, I like it. You're like, you're going to videotape me pushing buttons and then send it to you.
Yeah, I'm like, how do you show work?
Yeah. Anything else from homework stuff?
Yeah, can we do 71 from section 7.2?
This is 7.2, number 71. Okay. Is this the one that has that kind of thing, right? Yeah.
I just want to like see if I started it, but then I.
Yeah. All right. So unfortunately, a lot of people kind of gravitate towards this. This won't factor, right?
Okay, that
Go a little
was my
insane.
question.
Oh,
That's pretty much where I got stuck.
Do you see cubes in here somewhere? Yeah. And how do you factor cubes? Little do big dude. So that's going to be the big dude.
Okay, good.
So one of these. Yeah.
All right.
So anytime you see cubes in a problem, there might be a trinomial that can't be factored because the big dude can never be factored. So do the cubes first so you don't go insane trying to factor this dude. Is that cool? How do you factor the top of this?
Minus 4.
Yeah, 1x minus one of these 3/4. So then here's got to be the other two. It's squared.
Plus 4.
And at the end's got to be the other 2/4. So 1, 2, 3. 1, 2, 3. Bam! And then, of course, clean up, dude. Plus 4. Now, the only difference between that top and that bottom is that since that's a plus, that'll be a plus. And then that has to be a minus to clean up the stuff, right? And if that's x squared minus 4x plus 16, you flip this, that's going to cancel that. All right, I like it. And the only one left is in squares. It should be easy. Now, as much as I've talked about this, I saw a lot of people in the homework, way too many, doing stuff like, yay, go away, die, die. All right, what's wrong with that? Yeah, division can't cancel parts of subtraction or addition. It's not his job. It doesn't have that ability. Please understand that. Does everybody understand that? Don't do it. It's bad. Okay? 5/8 cannot be reduced. Even though 8 is 5 plus 3, who gives a shit? Division can't do anything about that. Can't kill those 5s. Okay, I like it. Okay. So please, if you're writing this down for notes, say that what I've got here is a mistake. Don't have this and say, this is what you said, Jeff. As an example of a mistake.
Can we do number 40 on section 7.4?
I don't know. Let's find out. 40. Ooh, yeah. All right. Now, let me ask you kind of a weird question. How would you put these together? Do they have an LCD? Do they have a light on there right now? Or they're not? No, they're not the same, right? So you could multiply top and bottom of this by -1.
But couldn't you just move the negative?
Totally. That's what ends up. That's the shortcut. What are we doing? We're multiplying top and bottom by -1. What's it look like happens? And negative goes up.
Yeah, you can just. it's the
Totally,
same
of course.
thing, Yeah.
It's the same thing because we're multiplying top and bottom by -1. All right, I like it. So this would become 1/6 minus 5/6, and then you get -4/6, and you get -2/3, blah, 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 blah. Who cares? So the problem is, where'd he go? Which one was it again? Third? No. 40?
Yeah.
Yeah. 7.4. I feel so bad for some people that do so much work on this thing. Oh, you could really go insane. But which one of those looks like the bottom is out of order? Doesn't really matter what you do this to, but let's say the first one's out of order, right? So I'm going to multiply top and bottom by what to make this become that?
Negative.
So then what's the top become? Yeah, so 6m minus 1. And this one becomes m cubed minus 1. And then you can keep going with that, right? There will be several more steps. You can factor the bottom. You can see if anything cancels once you put the tops together. Is everybody cool on that first step? These want to be the same. They're offset by a sign. So therefore, you give one of them a -1. So now they're the same. Put them together, see if it reduces.
And then the bottom's like big and little. Right?
Yes, cool. The bottom's another cubes, dude. Right? Little dude, big dude. Everybody all right with that? Bless you. You guys okay? Those of you that survived the weekend. I didn't check my roll today to see if anybody dropped. Oh. I say this, people think I'm heartless when I say that's less to grade, but no, I don't want anybody to drop. Okay, anything else? Nothing else from homework stuff? All right, we'll get back into where we left off. Oh, let's see, 8.1 we did. So let's get into 8.2. Maybe a quick couple problems from 8.1. This is on the test tomorrow. Crazy. So yeah, the test is going to cover through 8.2. So tomorrow, through 8.2 homework is due. Oh shit. A real quick word, real quick. I want you to do every single homework problem. And if you don't, I'm going to be like, finish that shit. You take it, make it your own, do what you can, get ready for the test. Don't come tomorrow not having done anything from chapter 8. That's insane. You're an insane person, right? If you have to, start doing every third odd instead of every third one. Just get some out of every section done so you're ready for the test tomorrow. Turn in what you've done. I'll give it back. Finish, that's correct. And you're like, okay, Jeff, I'll do that shit, but I just had to get ready for the test. Do you guys understand? I hate that when students are like, I couldn't do any of these last 5 problems because they didn't do any of that. And I'm like, what do you want me to do about this? What? I can't do shit after the fact. Yes.
You still get credit though, right, for trying?
You
Or
get
like
some.
for-
If you did enough, you'll get half credit, and then you can still finish it or correct it and get back up to full. Yeah. Okay, I'll lock it. You guys understand that? I mean, that's basically true about anything. I don't care what the teacher says. This is your education. You do what you can to learn this shit. That's what it's all about. I like it. All right. What's that symbol there mean? It means and. I like it. Looks like an A that lost the middle part. It also is called the intersection, which is kind of a nifty way to think about it. Where do these two intersect? Or what's in this and this? F and W. I like it. The and in English is very ambiguous. So if I said you have to be less than 5'3" and you have to weigh less than this to be a jockey, and, if you don't meet one of those, you're out. But if it said you and you come with me, it's not the person that is all three of you, it's just all three of you. So English, of course, one of the hardest languages to learn if you haven't learned it from birth, right? And means so many things. In math, it only means one thing. You have to be in this and in this period. So that would be F and W. Now if I were to put this symbol between them, A, B, F, W, or F, G, W, Z. I kind of said it as I wrote it, but that's the or symbol. It also stands for union, which is nice. Looks like a big old U. So you want to unite these two groups, right? So if I put all the men together with all the Democrats in this room and put them in a big group, I'm not going to suddenly have, if you're a man and a Democrat, there's not going to be a clone of you. Right? You don't write it twice. That's freaky. So what gets in here?
A, B, F, G.
Yeah, A, B, F, W, G, Z. You don't write these twice. U means union. Unite these groups into one big group. That's why the answer to a U and the answer to a union is always going to be bigger. The answer to an intersection, an and, is always going to be smaller. This is very restrictive. This is wide open. Mean bouncer. Nice bouncer. Right? Yes.
It's always going to be alphabetical order as well?
Who cares? I don't know. Yeah, did I do the alphabetical order? No. Yeah, I mean, you could argue. Yeah, you should. I don't know. As long as you got them all in there. Yeah.
Just with the bouncer thing, I mean, it really helped because I'm thinking as this frown and a smile.
Oh, I liked it. Yeah, that's good. Yeah. In a way. Come on inside. I like it. Yeah. I just rewatched Lego Movie. I think I caught a good count. All right. I like it. Okay, is that by itself cool? Now, obviously, this is not even, it doesn't feel mathematical, but this is math. Math is more than you think it is. Here's something that really looks very just math. You're right. Yeah, I like it. There it is. Cool. So what do you do for this guy? What's your first step? Yeah, solve each of those. I like it. So add 1, divide by 2, and subtract 2. So it's got to be greater than 4 and less than or equal to 10. So maybe this is like a summer camp for kids. You know, like the kids got to be older than 4. And they have to be less than 10. We don't want those over 10 kids coming in here and just trouncing these little kids. Right? So you got to be greater than 4 and less than 10. What goes in the 4? Greater than. What goes in the 4?
Open circle?
No.
Brackets?
No. Parenthesis. What's part of an open circle?
Oh, yeah. Whoops.
Parenthesis. And what goes on the 10? Bracket. Because what do you want to do with the 10? Do you want to include it or exclude it? Include. You want to include it, so you use a bracket. And, let's see if you guys like this. And always makes a sandwich, if anything. Or makes like this, stay away from it, right? Well, We'll see what happens. Yes?
Can you say it how you were saying it? And the x has to be.
Yeah, this really just says x has to be between 4 and 10, including 10. It's another way to say that. X has to be between 4 and 10, including 10. How do I write that interval notation? What's really funny about it is it's already there, basically. How do I write this in interval notation? Yeah, parentheses 4, up to 10 bracket. I like that. All right. Yes?
So, like, how would you explain it being like two brackets on both sides?
Oh,
What's the difference between two brackets on one side, like both sides, and the parentheses?
So how did I know ahead of time? When I created this, I created the damn thing, so I knew what the answer was going to be. Basically, I knew it was going to have a parenthesis because this one does not include the answer. Right? It doesn't include whatever ends up on this. It doesn't include 4. This one does include 10 because it's allowed to be equal to.
Oh, okay.
That's it. So if it's a greater than or a less than, it's going to be parentheses. It's not allowed to include it, so it's soft. Get really close to me, don't take. This is like, I always say the include is hard. It's like you can actually get here and pick it up. Yeah.
So in your little metaphor or something about the camp, it would be children above 4,
Mm-hmm.
and then the limit is 10?
Yeah.
Okay.
Yep.
That makes more sense. Okay.
I like it. So the minute you turn 11, get the hell out of here.
Just to reiterate, the bracket is the dark circle and the parenthesis is the open
Yeah,
circle.
this is related to, that's why I like this idea. If you wanted to put an open circle on it, you just put a parenthesis instead.
Okay.
And then this guy, include, so you use a bracket. It looks like part of an I for include. So this would be a closed circle. That would be an open circle. I like it. Okay. All right. So, let's get into 8.2. Now let me ask you, so let me ask you something. It's an absolute value. I mean, did we talk about this already? It's absolute value. So for example, what's the absolute value of negative 4?
Positive 4?
Why?
How many spaces away from
Yes.
0?
It's all about distance. So you're like 4 feet away from me, right? You're still 4 feet away from me. I don't care if I turn around. You're like negative 4 feet away. If you're negative 4 feet away from me, you're like in me somehow. Right? Great. So the absolute value of negative 4 is 4 because negative 4 is 4 ticks away from 0. Absolute value is all about distance. So the answer to the absolute value can never come out negative because that doesn't make sense. It's a very physical idea. It's nice. The only way it can come out not positive is if it's 0, of course. See, absolute value is 0. How far away is 0 away from 0? 0. Okay. And of course, that's neither positive nor negative. Yes?
So absolute value doesn't count the same way like parentheses or anything like that, so it's not a...
No, in order operations, it's the same level as parentheses.
Okay.
Just, I'll show you an example in a second. What's the absolute value of 7? 7, not negative 7. It doesn't change the sign. It's the most single-minded function. It says, whatever the hell it is, make sure it's positive. So if it's not positive, it does something. If it is positive, it doesn't do shit. Does that make sense? So it does 2 different things. Keep that in mind, what I just said. That function does 2 different things, depending on what the number is inside. Yeah?
Does it work exactly like parentheses? Like, can they work exactly like parentheses?
We'll get there. Hold on.
Okay.
I'm still on the basics.
Okay.
Yes. Okay? Yeah.
Okay, so you said a negative 4 is like 4 ticks away from 0, so why is it positive 4 ticks away from 0 as well?
Yes, of course. So what's the absolute value of 4? 4.
It's the spaces from 0.
Spaces from
The number of spaces from 0. Exactly. And you couldn't say negative. What would negative spaces away? How can you be negative feet away from me or something? Right, like I said, you'd be in some weird, different dimension of shit.
But wouldn't a negative 4 be negative 4 spaces away from 0?
That doesn't make sense. Right? Your house is so many miles away. It doesn't matter which way you look. If you said negative miles away, I'm like, do you live in the earth somehow? Do you, What does that negative mean? Does that make sense? You see that negative distance wouldn't make any sense. Okay, I like it. So, let's talk about this real quick. Before I bring in variables into this, let's talk about how this looks in an order operations problem. So for example, let's go to one that does not have absolute values in it real quick. Just give me a second here. All right, how would I do that?
In the parentheses, minus 5.
Yeah, in fact, take the square away. Let's not even, let's just focus on this stuff. So you do in the parentheses first, I love it. What's 2 minus 5?
Then 4 times
Negative 4 times negative 3 is 12. You could identify the very last thing to do, right? Subtraction is at the ass end of PEMDAS, right? So you do addition, subtraction last, unless it's inside parentheses, because then it goes first. Whatever's inside parentheses is first, no matter what the shit is, right? But if it's just out in the wild, it's got to go last. I have way too many people telling me this is negative 3 times, oh shit, no. I don't have 1 minus 4. I got 1 minus I don't know yet. Now I know 1 minus negative 12, 1 plus 12, 13. Now what would that look like with an absolute value instead? You still do in the grouping symbols first, right? In the absolute value symbols first. They're like parentheses, somebody straighten out. So what do you get inside there? What you get in 2 minus 5 is negative 3. Now what's the absolute value of negative 3? 3. Now the other thing is, now watch. I'm going to make a mistake right now, so don't even write this down. Yeah, wow. The operation. I have no idea what just happened. This is times. You can't make times become plus just like this. 2 times 8. Well, I'm going to make it 2 plus 8 because that's easy. What the shit? So it's still got to be times here. So I saw a few people making mistakes like that, where you're taking multiplication, making it become addition. And you'll see me say, multiplication can't become addition. What the hell? So it should be 1 minus 4 times what that is. So then I get 1 minus 12, negative 11. So of course it's a different answer because I put a different creature in there, right? Now this would have been 5 minus 2. This would have been the same answer because the absolute value would have not done anything to 5 minus 2. But in this case, it did something. So that's how it works in the order operations problems. Okay. It is parentheses, but then it's got its own last. You do inside, but then it's got one extra thing. If it's not positive, make it positive.
Well, I was just confused because it's like they don't talk about absolute value. Like with parentheses isn't absolute value.
I've seen people do, instead of PEMDAS, I've seen people do GEMDAS. That means grouping symbols.
Oh.
Parentheses. Because you can have parentheses, and then you can have like those symbols, and then you can have those symbols. My God, wouldn't you like that? Russian nesting dolls,
You
right?
would start with the parentheses.
You would start with the innermost stuff.
Right, got it.
You start here, and then you do this, and then you do this, and then you finally do that. Yeah.
And then you
It's
go.
inside out. Yeah. Whoa. I forget what they made that. Please excuse her. I don't know what that would be. I have no idea. All right. Golly, excuse me. No idea what that would be. I forget. But I've seen people make that a G instead for grouping symbol. And absolute value is a grouping symbol. It says do the inside for it groups the inside shit together. Does that make sense? Is that?
Yes. And then you just work left to right if you had 2 of them, like 2 separate. Same equation, just 2 separate, like a parentheses over here or an absolute value.
Oh yeah. Yeah.
Okay.
Yeah. So if I had like 7 plus 2 squared minus the absolute value of 2 minus 5.
So yes.
You do inside here, and then square. You do inside here, and then absolute value. Yeah. Okay. Now, so recall that absolute value, same place as parentheses. It's just got that one last thing. Once you do the inside, you make it positive if it isn't. Yes.
So for the absolute value, so you have negative 3.
So this is 81 minus, what's the absolute value of negative 3? 3. Yeah. People change those to plus, but you can't have this jump inside. You can't do that. Because really, if you do negative, what are you actually doing? You're multiplying them. Are you supposed to multiply before you do what these say? No, you can't do that. This is minus, I don't know. Now I know it's 81 minus 3. Yes?
Why would in some cases you distribute, but in other cases you do what's inside the parentheses first?
All right.
Question.
So here's this. You ready? The only time you distribute truly, the only time you want to do that is when you can't put the inside shit together. So I see stuff like this. I'm going to just pick on 2 minus 5. And then people write this out, 2 minus 5, 2 minus 5. Holy shit. Why? What is 2 minus 5? So I can figure out what I'm squaring. So when do I have to FOIL it? It's like that, because what is x minus 5? I don't freaking know. Okay, then I have to write it twice, foiling it. Foiling is something that gets you around order operations in a way. You rewrite it so then you can do different stuff to it. This is number shit. Yeah, I can figure out what that number is. I don't have to do any foiling stuff.
So we have variables where you have to FOIL it.
Yeah. Now, at the same time, tell me the difference between these two things. Actually, let's make it like that. I like. I mean, here, if I wanted to, I could distribute. Everything would be fine. Here, I can't bring something into an absolute value. I shouldn't. You sort of can, but you shouldn't. In both of these cases, you really should do this first. It makes it easier, right? So when would I have to figure out a different way? If one of these was a variable, then I'd have to figure out a different way. I'd have to try to distribute something. Okay, I like it. I love you guys.
I can't see it.
So you can't distribute an absolute value? Okay, so if you distribute in that absolute value, will you guaranteed always get the same answer like you will parentheses?
So what I'm trying to say is if you can't, for example, here's where you got to be careful. You can't like take a negative 2 out. Because the absolute value of negative 2 would be 2, so that if you're going to take something out, it would be 2. So there are ways to bring things in and take things out. You just have an extra level of being careful. And why do that shit when you don't have to, right?
Okay.
I like it. Okay. So let me blow your minds a little bit. What is this? Can't be that. It cannot be that, always. Because what could x be? What kind of number could x be? It could be negative or positive. If x is negative and you say this, you just said the absolute value equals a negative number. You guys understand the problem here. I don't know what x is. Well, how do I determine whether to do something or not with absolute values? It depends on what kind of number's inside. What kind of number's inside? An unknown one. Oh, shit.
Question mark. There you go.
No. I like that. I'll just skip that. I'll put a question mark next to all of them. No. Here's why I personally have a problem with this symbol at this level, for example. Because it does two things, like we said. It is not a single function, it's two functions. So tell me, what does it do if x is positive or 0? If that number is at least 0, what will it do to it? Will it do something? What's the absolute value of 2? 2. Did you do something to 2? No. So it would leave it alone. The absolute value of x would be x if x is at least 0. Does that make sense?
Yes.
If x is 0, absolute value of 0 is 0. It leaves it alone. Anything positive, it leaves it alone. Now, algebraically, how do you change something's sign? Not from Virgo to Aquarius. How do you change? So if x is negative, I have to change its sign. How do you change something's sign? You multiply by a negative. Now here's what blows people's minds. Now if x is negative, what's negative x? What's a negative times a negative? Positive. If x is negative, then the opposite of x is positive. These are the two things that this does, isn't it? What's the absolute value of negative 3? The opposite of negative 3, which is 3. Doesn't it change its sign? That's what it does. But it doesn't always do this. It only does this if the thing is negative to begin with. If it's positive, it actually doesn't do anything to it. It leaves it alone. That's why absolute value is a little bit evil. It's actually two different functions in one. Let me stop here for a second. Think about it. Is everybody cool with that idea? Of course, the minute you bring x's in, things have to get more complicated somewhere because they don't know what that number is. And the absolute value is all about what kind of number is it, then you know what to do. So this idea that there's two different possibilities has to make sense because I don't know what this shit it is. Yes?
So you just write that.
Okay, so this is the idea. Let's see how that idea affects problems. You might end up never writing this, ever. Okay, but you're going to use this idea. If I just put this. Now what could x be? Yeah, two different things, right? So what the inside of this, which is x, what number could I have put in there? I could have put 5 in there. So x could have been 5. Or x could have been negative 5. Well, yeah, they're not equal to. Okay, now does that make sense? That kind of jives with this. Let me show you this once. Because it might help somebody see a different way to do some problems. I don't like to teach it this way, but I might show you this a few different times. You could actually take this problem and write this as either x is 5, because that's this case, or negative x is 5, because that's this case. Because what's the absolute value of x? X or negative x. And that's where these two answers come from. But you see how we don't really need that? Either the inside is 5, or the inside is negative 5. I'm done. So how do I do? Yes?
No, I have a question. So, we have the smiley face, both.
You could, but there's no real need. That's mostly used for sets. Like there's huge collections of numbers that are the answer, yeah. So if you wrote 5 or negative 5, that's not wrong. It just looks weird to me, to be honest, because there's no need for that, yeah.
But you need to write or, you can't just do 5.
No, I mean, we've had multiple answers before. We didn't write order. I mean, if you wrote this, I'm fine.
Okay.
Yep. I like it.
That's in section 8.2?
8.2. 8.2 is absolute value equations and absolute value inequalities. So here, what do you guys think about this here? Now the thing on the inside could have either been, I really want you guys to realize, what's on the inside here? An unknown thing, right? So what could that unknown, that thing, 2x minus 1, that thing could have been what? It could have been, what do we take the absolute value up to get 11? You're trying to get what x is. I'm just talking about what the whole shit is. Whatever number this is, the absolute value of what is 11? 11. So either that thing is 11. If this thing is 11, wouldn't the absolute value of that be 11? If I replace that whole thing with 11, then the absolute value of it is 11. Or, what else? 2x minus 1 could have been negative 11. So what we got here is, if I just put empty space here and I say equals 6, what could I put in there? Negative 6 or positive 6. So whatever the hell this is, whatever this thing is, it either equals 6 or it equals negative 6. So if it was y equals 6 or y equals negative 6. If it was 3y minus 7, 3y minus 7 equals 6, or 3y minus 7 equals negative 6. Whatever's in here, I'm going to replace it with what would make it work. Because now what's the next level? Now I can figure out what x values make that happen. So with absolute values, there's always two cases. One is the inside's already the number it wants to be, because then the absolute value would just, okay, there you go. Or it's the opposite of what you want it to be, because then the absolute value would make it that thing. And then these are easy, right? Add 1 divided by 2, you get 6. Add 1 divided by 2, you get negative 5. Let me show you a different way. Now that we've seen the algebra, I think I like this better. Let me show you a different way to think about this that you're not going to use, really. Because it gets really difficult really quickly. But let me make an easy problem so you can see how this works. Let's do this one. Let's do this algebraically, and then I'll show you a visual way to think of this. How would I start this off algebraically? It's an absolute value problem. You know, there's going to be two cases.
X minus 1.
Yeah, either this thing is 4. One case is always leave everything alone. So take the absolute value out, right? Or that thing could be
Equals
negative 4. So x is 5. Or x is negative 3. Now watch. What's absolute value based on physically? The idea of distance. I like it. What does it say? It says, I want the distance between the number, that's the answer, and 1 to be 4. The answers will be the numbers that are 4 away from 1. Do you guys see that? Subtraction is difference between things. Absolute value makes it the distance. I want the distance between the number and 1 to be 4. So if I just put 1, if I go 4 up, where do I end up? Go 4 up from 1, you end up at 5. Holy shit. If I go 4 down from 1, 0, negative 1, negative 2, negative 3. Did you guys see that? Absolute value is distance, so an absolute value equation or inequality has to do something with distance. So in this case, it's I want the answers to be 4 away from 1, either up 4 or down 4. Do you have to ever do it this way? No. This is just a quick visual. Because to actually do this problem would be difficult. Once you start putting more shit in there, it gets a little further away from making immediate sense visually. This, totally, the number and 1 have to be 4 apart. So of course it's 5 and negative 3. Okay. So let's try one more here. And then we'll get into inequality stuff. Let's try 2 more, actually. Ha. Now in math models the real world. That's one use for it. It's not the only use for it. So I can certainly make an equation, a bogus equation. So for example, if I set up the equation where if I open a lemonade stand, what do I have to do to make $1 billion in 2 minutes? The equation should kind of go, no. Somewhere it should go no. So here, how is this bogus to begin with? There's no work I have to do. This is bogus.
Because it's a negative 3 on
Because it says the absolute value of something is negative. Is that possible? No. This is a little evil because you could write the 2 cases, you could work out the problem, you could get 2 answers, and both answers don't work. So sucks. So you have to look for this. When you see absolute value equals a negative, you just stop right there and say no solution. There's no way in hell this is going to work. Same way if I had this problem, which is in our future. Same idea. Both of those problems have the same answer for the same reason. Absolute value can't come out negative. Square roots can't come out negative. So no solution. Now real quick, if you did set up both cases, if you did do this, You see how you're going to get two answers? You are going to get answers, right? So if I subtract 4 divided by -3, I end up with 7/3. If I subtract 4 divided by -3, I end up with 1/3. And you circle it and you keep going, no. If you try to put 1/3 in, for example, what's 1/3 of 3? 1. 4 minus 1 is 3. Absolute value of 3 is 3. Oh shit, not -3. So don't do this. When you see this, absolute value equals this, no solution. Now, people are going to say, for this next problem, you're going to say, I could do something, you just said I can't. And I'm going to say, listen to what I quickly say. Because you can do something with this problem right now, right here. What's it look like, child? Let's do... The answer is not no solution. Because what's the big difference between this problem and every other problem we've done so far with absolute values? The absolute value is not by itself. Can you have a positive number minus 7 equal -3 all day long? Right? That's what this says. Positive number minus 7 equals -3. Of course that could happen. What minus 7 is -3? What do you take 7 away from to get -3? 4. So if this thing was 4, could the absolute value of something be equal to 4? Of course. Right? So what do? In fact, this is going to be a common thread throughout a lot of the equations we do. You isolate where your variable is, and then you do shit. So if I isolate, here's my variable. Is it by itself? No, it's got this extra shit. So what am I going to do to get rid of this? Add 7. So now I get 4 minus 3x absolute value equals 4. Is that good? Is that bogus? No, it's equal to a positive number. So far, so good. I can get the two answers. You guys see the difference there? Here, the absolute value is by itself already. Try to equal a negative number. Sorry, dude, you can't do that shit. No solution. Here, I took 7 away from the poor dude. I better add that over and say, oh, okay, if he's 4, that could happen. I'm going to get some answers. Yes?
What if is,
After you do that, it's still negative?
yeah.
Then you know it's bogus.
Okay.
Once you get the absolute value thing by itself, where your variable is, you can determine for sure if it's bogus or not. You don't stop here because it's equal negative. You get it by itself. Now you go, oh, it's not bogus. I have to do this. Oh. So what are the two cases from this?
4 minus 3 is 4.
Good. Good. So maybe a little bit freaky, but not too bad, hopefully. The 4's canceled, do you guys see that? -4, negative. And I always have somebody go, what the shit? Or they add 3 or something. It's really neat. But all you do, this side doesn't tell you what to do. This side does. Divide by -3. And of course, 0 divided by anything is 0. Or subtract 4, -3x equals -8, divided by -3x equals 8/3. Is that decent? Is that all right? Yes?
And the negative went away from that 8/3?
Yeah, the negatives
Cancel out?
cancel. Yep. Is that cool? Is that all right so far? It's only 9 o'clock. You guys don't want to break already, do you? All right, let's do a little bit more, then we'll take a break. I got to run back to the office and pick up these handouts anyway that I left back there, just to make my life more interesting. Okay. Absolute value inequalities. This is going to be more difficult because, for example, let's try to look at one visually to start with, like we did that one earlier. If I said, in fact, let's just do a very, very simple idea. Now, if this was an equal sign, the answer would be 4 or negative 4. Is that cool? This one says, I want the distance from 0, because there's nothing in there, it's like minus 0. I want the distance to be at most, what, 4. So therefore, if I start at 0, how far up can I go if I want the distance to be at most 4? I can go up to 4. I can't go any further. And I can go down to negative 4. And I can't go any further. That's a sandwich. Less thans are always going to be sandwiches. Less thans are related to and. I like it. Now, there's a couple different ways to write the two cases. The first way I'm going to write is the way that I don't suggest, but you can do it if you like it better. So this one is just purely us just directly thinking about it and making a visual of it, because it's a very simple inequality. I can do that. So I didn't actually use true algebra on this. I just kind of thought about it, right? So let me link it up to the algebra, because it's not always going to be this nice. One way to do this is to do my two cases. Let me see if you guys are cool with this. Let me bring back the real idea. What's the absolute value of x? It's either x, right? I'm not going to even put that. Or it's negative x. Okay, now. I don't recommend doing this. I don't. But what would I do first over here? And what happens to the sign? Switches. So don't you get the x is bigger than or equal to negative 4 and small or equal to 4, so it's contained. So pretty cool with that. That would always happen that way, right? I like it. Now, here's the better way. I don't suggest doing it this way. I suggest taking this problem. It's a less than problem. Less than problems are always going to be sandwich, right? I don't know if you can appreciate that word. A good sandwich is a sandwich, right? And me, I love the shit out of math, so it's a good sandwich. It's less than is always going to be a sandwich. Why? I always think about less than as you're going into a haunted house, right? And you're smart. You're not going to be like those dipshits on movies. Let's split up. No, shit, no. You stay within this close to me. You stay freaking close to me. We're not freaking, right? You with me? Less than is, I don't want you to get more than this away from me. I want you to be less than 4 feet away from me at all times. You guys understand that? So less than is going into a haunted house. Greater than is somehow related to a restraining order. Greater than is stay the hell away from me. So this one is stay close to me. So watch how I can rewrite this. I want this to go up to 4. You can go up to 4 feet that way, or you can go down that way. You've got to stay within 4 from me. So you can go up to 4, and that's exactly the idea of the visual. So let me show you a true, full problem, what it would look like, because that was too simple. So less than, stay close to me. It's a sandwich. So have you guys ever seen a 3-sided inequality before? Hopefully. It's got the left side, the right side, and the inside, right? So it's a 3-sided inequality. It just means, now, in order for this to make physical sense, that number has to be less than that number. So if you put 2 less equal to x less equal to negative 7, that don't make a damn bit of sense. So if I have this, let's start with one that you'll see in the homework, this kind of thing. 3x plus 7 less than, it doesn't matter, Jeff, 2. So the way I highly recommend you do this. And if you don't want to do it this way, you can do it the 2 cases way. You just have to remember, it's an and for less than. I don't like doing that myself. I like thinking less than, stay close to me. So that means that this thing can get up to 2 or down to negative 2. And now I don't have so much shit to write. I just got this one thing to work with. How do I start getting x by itself? And where do? You always do the thing to all sides. Normally we say both sides because we only have two sides. Here I do -7 to all sides. So then I get -9 less than 3x less than -5. Divide by 3. -3 less than x less than -5/3. Yes, sir.
So when we're dealing with the inequalities on all sides,
When you have a less than, you can write it like this, because less than means stay close to me. I want the distance between you and me to be less than something. I want you to be close to me, so it's going to make this. Greater than says, I want you to be at least this far away from me. That's why it sounds to me like a restraining order. Sorry if I'm bringing up bad memories for anybody in here. But it's like, stay the hell away from me. I want the distance between you and me to be bigger than something. Do you see how I'm doing this? So the answer is going to look like this. It's going to have one set of answers up there, one set of answers down there. Stay away from it. How do I, now you can graph this in interval notation, this, right? Shouldn't be a big deal. So it's from -3 up to 5/3. What symbols do you put on those? -5. Parentheses, I love it. If it had a less than there, then it would have been brackets. Interval notation is really easy for this, right? It's basically the answers there. Parentheses, -3 up to -5/3, parentheses, bam, bam, bam. Yes?
Question, why is it -2 all the way to the left when it's not less than or equal to? Right?
Oh, the equal to only, if the only difference between this problem and this problem, that equal to means it's going to be brackets. It's the only thing that means.
Okay, so why did you subtract 2 on the left then? You just put it on that
Well,
side?
so that, what this is saying is that number can go up to 2 or it can go down to -2.
Okay.
So how can I always rewrite absolute value something less than or less than equal to something? It's just going to go that something there and the negative of that thing there. I love the idea of you can go up this far, you can go down this far, but stay close to me, right?
Does this work for more than?
Oh, yeah, so greater than we're going to talk about right now. Greater than is going to look a little bit different. Yeah. So this is the one I called the restraining order.